As you all know, Egypt is suffering a huge energy wasting problem. Since Egyptians lack awareness regarding energy wasting, according to recent studies, 15% of electrical energy is wasted daily on unused electrical appliances, including room lights that nobody is using. So we thought of a highly applicable solution, which simply revolves around the idea of counting the number of people in a room, entering a room and exiting this room, and automatically switches off the light when nobody's inside.
So the inputs and outputs are as follows. We have created a system consisting of two sensors, two passive infrared sensors that detect objects in front of these sensors, and we have used two to be able to determine the direction of the movement. For example, if you have sensor 1 and sensor 2, and sensor 1 is being the closest to the door, if a person passes through sensor 1 and then passes through sensor 2, that means that he is entering the room. Then we can be able to increment the counter. And vice versa, if this person is leaving the room, then he will pass through sensor 2 and then sensor 1, and this way we can decrement the counter. We have also the LED. We have also the switches, a manual switch, so that a person can turn on the light and turn off the light manually. And we have LED, and we have a lamp, and we have a LED on the Altera board, which resembles a real lamp. We have two digits of the 7-segment display, LED display. One is to represent the number of people in the room, and the other one is to represent which state we are present in the finite state machine. And that's it.
Okay, so my name is Alia, and I want to tell you now about the idea of the code itself, which is a finite state machine, the Moore model, which is only depending on the current state. So we start with state 0, which means I didn't get any input or output yet from the sensors. If I get an input from sensor 1, I go to state 1. In state 1, I wait for an input from sensor 2. If I get an input from sensor 2 and my sensor 1 is off, I go to state 3. State 3 basically means that someone entered the room. I got sensor 1 and then I got sensor 2. So it increments the counter. This is state 2. It increments the counter and then reverts back to state 0 when both sensors are off. If I was in state 0 and I got an input from sensor 2, I go to state 3. In state 3, I wait for an input from sensor 1. If I get an input from sensor 1 and my sensor 2 is off, then I go to state 4, which is my final state. State 4 basically means that someone is exiting the room. I activated sensor 2 and then I activated sensor 1. When both sensors are off, I decrement the counter and then I revert back to state 0.
Hello, my name is Emad. So as Alia and Ahmed mentioned, we use two sensors to simulate the movement of someone entering or leaving the room. Here we bought two sensors, sensor 1 and sensor 2. And after working, we found out that sensor 2 required higher voltage than sensor 1. So after many research, we connected the higher requirement sensor to this pin, which is 5 volts, and the other, which is lower, to the other pin, which is 3 volts with its ground. And then we connected the outputs of the two sensors to the input of the Altera, to the first two general pins. And we used this switch to simulate the switch of a light in a normal room, assuming someone wants to switch off the light without using the sensors. And we used this button to reset the values.
Hello, my name is Ebram. I'm going to talk about the implementation of the code. So the basic idea is that we have two sensors, which are our inputs, as well as a switch. And we have 3 outputs, which is the LED to simulate the light of the room, as well as 2 BCD 7 segments, one to display the count of the number of people inside the room, and the other one to display in which state the finite machine is. During our work, we figured out that the sensors we are using, they fluctuate on input, meaning that if someone passes in front of the sensor, it's an active low sensor, so it like goes 1 0 1 0 1 0, which like made our finite state machine malfunction. So we had to figure out a way to solve this problem. So what we did is that we implemented a clock that triggers every 1 second. This was by using the built-in 50 megahertz clock in the Altera. And what we did is that we made an always clock that triggers at the built-in clock, and it counts from 1 to 50 million. And once it reaches 50 million, it outputs 1. Otherwise, it increments the count and outputs 0. So in the main module, we call this delay module. And then inside the main module, we check every second for the inputs of the sensor. And then there is like temporary variables which hold the values of the sensors at each second. And then there's another always block that is triggered at these 2 temporary values, which handles the finite state machine. The finite state machine basically works as Alia described. And then there's another always block, which checks if the count is 0, or if the switch is turned off, then it turns off the light, else it turns on the light. And then there are other 2 always blocks to check on the count and the current state, to display the state and to display the count of people inside the room. So this is the basic idea of our code.
So now we simulate the movement to see how the machine exactly works. Okay, now I'm moving in front of sensor 1. As you can see, it can see my movement. And then as we see on the LED, it moves to state number 1. After that, I'm moving in front of the second sensor, which then is supposed to go to state 2. So as you can see, it got state 2. And now I moved outside the range, and a colleague of mine will do the same. And we'll assume that another person is entering the room with the same behavior. So now as you can see, it called that 3 people are in the room, and then it returned back to state 0. And the button, the light is on, so people are in the room. Now we'll do the otherwise. We'll go outside of the room, so sensor 2, then sensor 1. Another colleague of mine will do the same. And then me again. So as we can see on the LED, it is now in state 0, showing that 0 people are in the room and the light is turned off.